So our issue today is about the observation of the long-term circulation in the northern East China Sea. So why should we care about the northern East China Sea? Because it's located between the open Pacific and neighboring marginal sea. So namely, is the center of the exchange of the place that exchange the heat and material. And what is the thermal highlight front? In oceanography, the front is the boundary between two different water masses, and the word thermal highlight means the temperature and salinity. So it's so-called the thermal highlight front. And there is a current in the northern East China Sea. So as you see, the Korea coastal current and the East China coastal currents and the East China Sea currents transport the low temperature and low salinity southward. And the Yellow Sea warm current and Jeju warm current are both the branches of the Tsushima warm current. They all transported the high salinity and temperatures northward. So the East China Sea current and the Korea coastal current will converge with the YSWC and CWC in the northern China Sea to form the strong surface thermal highlight front, as the red dashed line shows. And the name of this front is Jeju Yangtze Front, named CYF. And the CYF could divide it into the northern warm tongue, like the red line, and the southern cold tongue as the right. And the warm tongue could divide it into the northern front along the 34° of north latitude, and the southern front in direction of the northwest and to southeast. And the frontal circulation pattern of the CYF is the counterclockwise flow rotating here, and the flow is contain the westward transverse current and the southeastward current named SO. So the purpose of this study is because there is many studies that examine the structure of the northern front, so we aim to analyze the structure of the southern front of the long term and identify relevant frontal circulation from the perspective of heat and material exchange. Those were based on the in-situation data observed at 40 meters deep during 2017 and 2018. And also the historical data has a 58-year and satellite altimetry derived sea surface height, means the sea surface height data is come from a satellite, briefly. So there is the full discussion of the result, and first of all we will talk about the surface geostrophic current is weaker in spring than in winter. So thus the surface cyclonic currents only exist in February. So this is a figure that shows the maps of geostrophic current. The black arrow is a geostrophic current, and you can see there is a circulation here and here, but you cannot see it in April as spring. So these are the figure that shows also the geostrophic current. And the left panel is observed at 2017, is the annual mean of SGC, and the right panel is observed at 2018, is the annual mean too. So as you see, you cannot find the SCC here and here. So these are the April data of SGC, and you also cannot see the circulation here and here. But these two are the February data, and you can clearly find a circulation here and here in both years. So our first discussion is proved. And next, we'll move on to the surface frontal structure. And this on the figure that shows the surface sea surface height, sea surface temperature as the color shows, and you can clearly see the S-shaped surface frontal structure here. But you cannot see the SFS named surface frontal structure in April and in annual mean. So our second point of the surface frontal structure is weaker in April than in February are checked. And we'll move on to alternate intruding frontal structure in lower layer. So before talking about the AIFS, we will define the standard of the high temp and low temp, and the high salinity and low salinity. And the standard of the temperature is 11.5 degrees Celsius and 33.4 gram per kilogram in situ data of salinity, but in historical data is 33.7 gram per kilogram. And as we talked previously, the Yellow Sea warm currents and the East China Sea currents will convert in Northern East China Sea to form the frontal structure, and as well as it can be found as the lower deep as well. So the left panel is the in situ data observed at the February, and the right is historical data of February during past 58 years. And the location of the low temp and low temp salinity water from the East China Sea is located here. And next, these two pages are same as the previous slide, but we mark the distribution of the high temperature and high salinity water from the Yellow Sea warm current. And these two features is observed at the April, and the left is in situ data in 2018, and the right is the historical data. And so the low temperature and low salinity water's distribution is located here. And high temperature and high salinity water is here. So we can clearly find the alternate intruding structure along here and here, because if you remember the next slide, the position of the low temperature and low salinity. So the AIFS is both found in two seasons are clear, and we've left the near bottom cyclonic circulation. So these are the black arrow is the surface geostrophic current, and the red arrows are the in situ data that observed in February 2017. And as you can see, there is a cyclonic circulation in the lower layer here and here. And in the winter as well as February, the circulation consists of the TC, the westward flowing, the westward transversal currents, and the SOs, the southeastward outflow. Although the surface geostrophic current isn't clear at the spring, but we can also find the circulation at lower layer here and here. So our final conclusion is proved. And let's move on to conclusion. So this is a schematic diagrams of the cross-frontal circulation, And as you can see as the previous diagram of temperature and SGC, and how the near-Barton circulation contribute to exchange the material, because it brings the materials from the transient bank toward the northeastward of toward the southwestward of the Jeju Island, and some of the materials will return to the Yellow Sea by joining the Yellow Sea current. And to summarize, in April, the AFS is still confined along the sea line in both seasons, and is produced by the cyclonic circulation. And the cyclonic circulation is clear from whole water column in February, isn't up there in April. So that's why we name it near bottom and semi-permanent. And the semi-permanently cyclonic circulation is found even from the maps of surface geostrophic current in February in both years, while it is not in April. So supporting only near bottom cyclonic circulation maintained in April. And here is our method. So all the vertical profiles of temperature and salinity were observed by the CTD in the cruises during the 2017 and 2018. And all the vertical profiles of the horizontal current were observed by the ADCP. And the historical data is from the NIFS, National Institute Fisheries Situation, and the satellite data is about the 0 to 0.25 degree horizontal resolution. And any questions?
Okay.
I want to know what is geostrophic current.
Repeat her question.
So, what is geostrophic current? And as you see, if some reason lead to the sea surface height is relatively high somewhere here, and the pressure distribution on a horizontal surface below the surface and is a uniform, therefore produce a pressure gradient force, and which makes the water flows. And after the water flows, the Coriolis flows will drive the water flows to right immediately in the northern hemisphere. So due to the equilibrium of the PGF and the Coriolis flows, the final direction of the water flow is perpendicular to the direction of the PGF. And this kind of ocean current is so-called geostrophic current.
Jaden.
I know the cold current like Korean coastal current and China coastal current has a low temperature, but I wonder why it has the low salinity, because I think coastal current has many sediment from land. It should be high salinity. Yeah, thank you.
Repeat his question.
The coastal current so you want to know why the Korea coastal current and the China coastal current carries the relatively low high salinity? Sorry, I don't know. So I can answer your question, but we will figure out maybe after presentation.
Kelvin.
Do those circulation correspond to seasons, or it just happens all the time?
Repeat.
You mean the nearby circulation is throughout the year or is seasonal? So by the previous results we have mentioned, and the circulation only exists in the spring and winter, but it's not found out all the year. So this is why it's semi-permanently, and yeah.
Next.
I'm going to ask the basic questions. Why can investigating the currents benefits? What is the reason of investigating those currents? What can it benefit?
You mean why we should talk about the currents in the previous part? Or you mean the other means?
I mean,
The benefit of observing the current?
yes, and that's all.
What do you mean the
Why
benefit?
should we study currents?
Oh, why do we have sorry. So as you see, these currents is connected. Sorry, the frontal is connected. The northwest of part of Jeju Island and is southwest of the Changjiang Bank, and it is because there is a current here and here transport low temperature water toward here, and so we will form this frontal structure, and this is important because it means a lot to the exchanging of heat in the polar or the equatorial equator.
All right. So Jessie gave a very fluent talk. So she spoke actually a little bit fast, considering the difficulty of the topic. I would suggest that next time you have to speak a little bit slower. And to do that, you really need to reduce the content of your topic. So I saw that you have 4 major topics you want to talk about. I would suggest that maybe you have to think which one is least important. So you take out one, and then you use more time to spend these difficult topic, because these might be familiar to you but not familiar to other students. And the purpose is for these students to understand what you are talking about. All right. So first of all, the first thing is as you have noticed that this paper has a lot of abbreviations, like this, that, etc., etc. And these abbreviations, they are fine for papers, but they are actually not good for presentations, because abbreviations are very easy to forget. Yeah, and then later on you introduce even more abbreviations that's even more confusing. Like here, you start to use SGC, SCC, FSCL, FSN, BCC. So I start to get really confused. I don't know what you are talking about.
Because I want to let the text in the minimum sentences.
Okay, I see your point. But this, when you read this way, is not really helping communication. So I would suggest if you really need to, for example, use SGC or this, whenever you use this, for example, even after 2 slides later, I already forget what is SGC. So one tip of doing that better is you use the space here and type SGC is equal to what? Because otherwise it's really difficult for us to know what these are about. And then another point is there are a lot of currents, and these currents, I think it's later, these currents like this, maybe it's fine for me, like I know what is YSWC, but not everybody. So one way to improve this is you always put this map, not this one, where's that one? This map, or even a cleaner map, where you show the location of these currents next to in the slides. You can make it smaller, or you can retype this abbreviation, make it bigger and more visible to the audience in all the slides where you talk about the currents. Otherwise, it's so easy to get lost. And then another issue is you talk about this transect, and this is again another confusing issue because I don't remember where they are anymore. So I don't know what you're talking about actually. So it's always good. It's actually, I don't know where it is. I think maybe it's this one. But it's not mentioned in your talk. So again, you need to put the map every place because your study is really related to space, to the location of different things, and please use map to guide the audience. Otherwise, we are lost. And therefore, that's the reason I would suggest that you remove one of your 4 topics and help us to understand all the other topics. For example, I assume the topic geostrophic currents is important. Then it would be good if you can introduce geostrophic current as a point, because one of the audience students asked this question already. I also have that question because I'm not physical oceanographer. And then you already prepared that. I saw it. It's really nice. Although I would say it's a little bit too much text, so it's difficult for me again. So you see, so it would be nice if you can explain it in easier word, and that needs to be practiced. Yeah. Okay. Yeah. And then so because map are so important to you, so I would suggest that in your conclusion, for example, I would say this is actually nice. I would almost think it's, yeah, you use it sort of for your conclusion. That's a good choice. But later on, there's another summary slide. I again get confused. So it would be good that you always direct the audience back to your topic with the help of maps. Yeah, you really need maps. And yeah, and then this slide is really unnecessary. Yeah. If I were you, what I would do is I would put a photo of CTD, I would put a photo of AECP, that's it. Yeah. There's no meaning for this, forget already. Yeah. And yeah, but you spoke very fluently, and I can see that you can do much better. So I will encourage you to next time to stand here closer to your slides. Maybe use some body language, like smiling. With masks, we don't know you are smiling, but you can see it from your eyes. Smiling to the audience. That will give you an even better stage performance, given your nice English skills. Yeah, it's a difficult topic, so I acknowledge your efforts. You have done a good job, so we hope to see your improvement next time. Okay, thank you, Jessie.